A differential equation is any equation that involves a derivative. A first order differential equation, which I'm going to call DE, is an equation that has a first derivative in it. For example, it could be an equation that says dy over dx equals 2x minus 3, or it could be 2y times dy dx equals 1. It's got a first derivative in it. A second order differential equation has a second derivative in it. And so it could be something like the second derivative is equal to x cubed minus 1, but it could also be like the second derivative plus 2 times the first derivative plus 4y equals 0. So it's an equation that has, in terms of its highest derivative power, that would be the second derivative. You will be expected to solve an equation like this, or something slightly harder than it, but in that form. An equation like this, you won't be asked to solve at level 3. Something like this could pop up in your differentiation exam, where you're differentiating and substituting into this, but that's the only time where you'll see it, at level 3. So, a couple of examples. You could have something that says dy dx is equal to 2 over x, and you're told that the curve passes through the point 2, negative 1. So firstly, we're going to integrate this. When we integrate dy dx, we get to y. It's just the opposite of differentiation. And 2 over x goes to 2 ln x, and then plus our constant c. This here is called a general solution because it still has the unknown constant in it. When we substitute the point to find c, we then get something called a particular solution. So subbing in to negative 1, you get negative 1 equals 2 ln 2 plus c, which means c equals negative 1 minus 2 ln 2. You don't need the absolute value bars for ln anymore because 2 is a positive number. That gives you approximately negative 2.386. So your solution to this is y equals 2 ln x minus 2.386. So when you have a question that has a differential equation in it, most likely the question will say solve. And when it says solve, it actually just means get an equation for y equals in terms of x. Second problem, you're told that the second derivative is equal to 4e to the power of 2x minus 3. You're told that when x equals 0, the first derivative is equal to 0. And you're told that when x equals 1, y equals 3. You're given two pieces of information because having a second derivative means you'll have to integrate twice, which will give you two unknown constants. Differentiating the first time, we get dy dx is equal to 4e to the power of 2x over 2 minus 3x plus c. Now simplifying first always, that gives you 2e to the power of 2x minus 3x plus c. Now that we have an equation for dy dx, we can substitute this condition. So we have dy dx is 0, so that will be 0 equals 2e to the power of 2 times, and x is also 0 in this case, minus 3 times 0 plus c. Solving that will give you c equals negative 2. So we have an equation that says dy dx equals 2e to the power of 2x minus 3x minus 2. Now we have a first order differential equation. We can integrate this again to get our y equals. So we get y equals 2e to the power of 2x integrates to e to the power of 2x minus 3x squared over 2 minus 2x plus d. I'm using d here because c has already been set. If you want to continue using c, you can use c1 and c2. Now we can plug in our other condition, x equals 1, y equals 3. So 3 equals e to the power of 2 times 1 minus 3 times 1 squared over 2 minus 2 times 1 plus d. And when you solve that, you're going to get d equals 5 minus e to the power of 2 plus 3 over 2, which is negative 0.88923 decimal places. And so our final solution to this is y equals e to the power of 2x minus 3x squared over 2 minus 2x minus 0.889. And that is our particular solution. For a final example, we have the second derivative is equal to 12x squared plus 2 over x cubed, and we're told that the curve passes through 1, 4 and 2, 43 halves. Solve this differential equation. Before we can integrate, we need to rewrite this as the second derivative equals 12x squared plus 2x to the power negative 3, and then we can integrate. We're going to get dy dx equals 12x squared integrates to 12x cubed over 3, or 4x cubed, and then 2x to the power of negative 3 integrates to 2x to the power of negative 2 over negative 2, which is negative x to the power of negative 2 plus c. This time I'm going to use c1. We don't have a condition that has derivatives, so we need to integrate again. So y equals, now we get 4x to the power of 4 over 4, which is just x to the power of 4, and minus x to the power of negative 1 over negative 1, which is just plus x to the power of negative 1, plus c1x plus c2, which simplifies to y equals x to the power of 4 plus 1 over x plus c1x plus c2. And now I can substitute my 2 points to get an equation for c1 and c2 and then solve simultaneously. So the point 1, 4 goes to 4 equals 1 to the power of 4 is just 1 plus 1 over 1, which is just 1, plus c1 times 1, which is just c1, then plus c2, which simplifies to give c1 plus c2 equals 2. The other point, 2 and 43 halves, that gives 43 over 2 equals 2 to the power of 4, or that's 2, 4, 8, 16, plus 1 over 2, plus 2c1, plus c2. That simplifies to give 2c1 plus c2 equals 5. Now we have two equations with two unknowns. We can put them on top of each other. We have 2c1 plus c2 equals 5, and c1 plus c2 equals 2. Of course, you can now use your calculator to solve for the simultaneous equations, but you can also just subtract. 2c1 minus c1 is just c1, c2 minus c2 is 0, and 5 minus 2 is 3, so c1 is 3, which means that since c1 plus c2 equals 2, we now have 3 plus c2 equals 2, and so c2 will equal negative 1. giving us a final solved equation of y equals x to the power of 4 plus 1 over x plus 3x minus 1.